Hey guys, how you doing? Today we're setting off on an imaginative journey toward the nearest black hole. Let's make yourself comfortable and come travel through space with me. If we move at the highest speed ever, it would take us a whole 77,000 years to get to the nearest star. It would also take us more than 1 billion years to cross the Milky Way galaxy. But luckily, we are traveling with immense fast speed. Let the journey begin. The Earth goes smaller and smaller by the second. It seems like no time has passed, but we are already 200 miles above the surface of our planet. Since it's daytime, we can clearly see the Great Lakes shining in the sun. Now we've just spotted something moving. It's the International Space Station. Did you know that the station is the most expensive single object in the world? No wonder, with a price tag of $100 billion. This money would buy you 250 Boeing 747s or 2 Louvres with all the paintings and artwork inside. The length of the station is over 350 feet, which is more than the length of a football field. But we don't have time to linger. Black hole is calling for us. Now we're about 1,300 miles over the surface of the planet. Here we can spot satellites here and there. Among satellites, there are low and high flyers. And while the lowest flying ones move approximately 1,250 miles away from Earth, which is the length of 4.5 Grand Canyons, the highest reach 22,000 miles into space, which almost equals the Earth's circumference, measuring about 25,000 miles. By the way, few people know that satellites travel at a blinding speed from 7,000 to 18,000 miles per hour. Also, the higher a satellite is, the slower it moves, relatively speaking. For example, the weather tracking goes, system of satellites orbits the Earth once a day at a distance of 22,000 miles above your head and reaches a maximum speed of 7,000 miles per hour. Well, the satellites are being left behind and taking us toward the moon about 240,000 miles away from Earth. That's the same distance you would go if you went around our planet 10 times in a row. At this point, Earth looks like a small, bright blue ball hanging in the middle of nowhere. From this point, we can clearly see that the moon isn't a perfect sphere. It's shaped more like like an egg. We're headed somewhere even further. We see Mars, Jupiter, Saturn, and Neptune passing by in all their glory. And look, here's Pluto, who used to be a planet but was later demoted. From here, Earth looks like a small star that's getting fainter and fainter as we're moving further away. Right now, we're already really far from Earth, like 100 astronomical units away. The thing is that space distances are so vast you can't even calculate them in miles. That's why scientists use the term astronomic unit, which equals 93 million miles, the distance from the Sun to Earth. That means right now, I'm 9.3 billion miles away from our planet. Now we're entering the termination shock, the place where solar winds coming from the Sun travel at a speed of 250 miles per second and collide with the material that makes up the galaxy's background. Here's another trial ahead, the Oort cloud. That means two things. First, we're on the outskirts of the solar system, and second, we'll have to get through a cloud of icy objects orbiting the Sun at a distance of 100,000 astronomic units. In other words, it's 1.87 light-years away from our star. So now we're heading out of the solar system just 1/10 of a light-year later. By the way, if you were trying to reach this point by car, the trip would take you more than 19 million years. And even if you piloted one of the fastest spacecraft that exists nowadays, NASA's New Horizons, you would still need 37,000 years to complete the journey. So bring a big lunch. All right, we've left the borders of the solar system, and now we can watch comets and asteroids pass by. In the center of pretty much every galaxy, there's a supermassive black hole. For example, one is sitting right at the heart of our Milky Way galaxy, about 27,000 light-years away from Earth. But our destination is the stellar black hole nearest to Earth, and much smaller in size but no less mysterious. It's V616 Mod Oceratus, also known as V616 Mod, located 3,000 light-years away and weighing the same as about 9 to 13 of our suns. A black hole is an eerie place where those laws of physics we studied at school stop working. If a massive star runs out of its star fuel, it becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new thing gets so strong that nothing can escape it, not even light. So, we're approaching the black hole. We won't go further than the horizon, also known as the point of no return. And you can probably guess why, right? Once an object crosses this invisible line, it can't turn back, even if it changed its mind. Anyway, bravely plunging toward the black hole, keep on accelerating. If we move further, we will feel contorting and stretching. Interestingly, the closer to the horizon, the more slowly we'll seem to move. And then some force will be stretching us thinner and thinner. It's the infamous spaghettification, which happens in a super strong, non-homogeneous gravitational field. The black hole's gravity force will be stronger at our feet than at our head. That's why we'll be getting stretched out like a piece of spaghetti. And then we'll be in the state of freefall now, and feels no more stretching, scalding radiation or gravity. What about you? Do you think I should go all the way and we should explore more about black hole next time? Let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend.